The EDIT Tower. Sustainable architecture attempts to reduce the collective environmental impacts during the production of building components, during the construction process, as well as during the life cycle of the building. And as an example, we talk about the EDIT Tower project in Singapore. The EDIT Tower project is created by the architect Ken Jeong. Dr. Jeong's proposal for the EDIT Towers won the 1998 competition for ecological design in the tropics, and the building will be released at the junction of Waterloo Road and Middle Road in Singapore. Dr. Ken Jeong's work is featured in the brand new Eco-Design Handbook. The project design integrates green space to human use area in a radius of 1-2. A particularly important point in the design of the organic compounds is the survival of plant life in the neighborhood of the building to ensure that the plants incorporated in the building project do not compete with indigenous species. The design set out to demonstrate an ecological approach to tower design. The building has the following ecological response. Response to the site ecology. Ecological design starts with looking at the site's ecosystem and its property. Any design that does not take this aspect of the site into consideration is essentially not an ecological approach. Design begins with the mapping in detail in the indigenous planting within a 1-mile radius vicinity of the site to identify species to be incorporated in the design that will not compete with the indigenous species of the locality. Loose fit. Generally, buildings have lifespan of 100–150 years and change usage over time. The design here is loose fit to facilitate future reuse, for example, removable partitions, removable floors, mechanical jointing of material as against to chemical bonding to facilitate future recovery. Flexible design, for example, initially a multi-use spot building. Its future use may be office or apartments. Vertical landscaping. Vegetation from street-level spirals upwards at a continuous ecosystem facilitating species migration, engendering a more diverse ecosystem and greater ecosystem stability, and to facilitate ambient cooling of the facade. Species are selected not to compete with other within surroundings. Vegetation percentage represent of area's landscape character. Factors influencing planting selections are planting depth, light quality, maintenance levels, access, orientation, wind walls, solar panels, special glazing. Vegetation placement within the tower at different heights responds to the microclimates of each individual subzone at the tower. Water recycling. Water self-sufficiency by rainwater collection and rainwater reuse in the tower is at 55%. Water purification. Rainwater collection system compress the roof's catchment fan and layers of scallops located at the building's facade to catch rainwater running off its sides. Water flows through gravity-fed water purification system using solid-bed filters. The filtered water accumulates in the basement storage tank and is pumped to the upper-level storage tanks to reuse, for example, for plants irrigation and toilet flushing. Mains water is only here for potable needs. Sewage recycling. The design optimizes recovery and recycling of sewage waste. Sewage is treated to create compost, fertilizer for use elsewhere, or biogas fuel. Building materials recycling and reuse. The design has an inbuilt waste management system. The recyclable materials are separated at source by hoovers at every floor. This drops down to the basement waste separator, then taken elsewhere by recycling garbage collection for recycling. The building is designed to have mechanically joined connection of materials and is a structural connection to facilitate future reuse and recycling at the end of the building's useful life. Natural ventilation. Wind is used to create internal convection of comfort by wind walls. Thus are placed parallel to the prevailing wind to direct wind to internal space and sky cord for comfort cooling. We can conclude that the design of this building is sustainable because it has the ability to benefit from the elements like rain, sun, wind, reducing energy costs that any building will need. It's a self-sufficient building. Not to mention that the EDIT Tower is intended to be used in the future for other activities. For this and other reasons mentioned, EDIT Tower is a building designed with the principles of sustainable architecture.